for this problem on workbook page 144. You should have, oh, hold it. No, I haven't. Ha, ha, ha. Okay. You should use this formula. A sub n is equal to A sub 1 times R to the n minus 1. Okay, and that's straight off the formula sheet. And I just taped mine in the front of my workbook. I'm going to give you a new formula sheet for your tests. Now, so let's look at it. You're given in number 1 that A sub 1 is 5. You're also given that R is 3. And you're given that n is 6. I mean, this is straight up plugging in a number. Okay? Lindsay, do you mind cutting the calculator on for me? There you are. All right, thank you, dear. All righty. All right, so let's look. 3 raised to the 5th power is 243. Did I have the wrong answer? No? 1215. I mean, that's about as basic as it gets. That's my birthday. Kind of excitable. Cool with that? Do you see where you made your mistake? Yeah? Yes, sir. All right, if I'm good on 1, are you good with number 2? Because it's the same type problem. The same information is given. Number 4, that's a good one. You got, it's the same thing that I said. Number 5 is 3 over 64. Let's look at that one. Number 4, yeah. Okay. All right, it's all right. So which one am I doing? 5? Christian, no, you found it? Or holy crap. Yes, sir. You're welcome, sir. Attaboy. Do I need to do a problem on the board? Number 5? Number 6, I do need to do 4. Are we collectively saying yes on number 4? Yes, you need to say 4. Okay. Holy moly. Folks, here we go. It says A sub 8. That's what we've got to find. 4, negative, this. Is that all we're given in that problem? ... All right, so we're talking about geometric, so I've got to use the correct formula, which is the same formula I just used because we're still dealing with the sequence. So it's A sub n, A sub 1 r 1 minus n, I think. I don't trust myself. N minus 1. Okay, so folks, this is going to prepare you for the test. If it says to find A sub 8, what does that 8 represent? The number. The what variable in this formula? N. This means there are 8 terms, and we're looking for that 8th term, correct? So A sub 8. What is my first term, A sub 1? Negative 1 over 250. My ratio, I don't know what it is, but I know how to find it. How can I find my ratio? Take the second term and divide it by the first term. And folks, this is all calculator work right here. I mean, even I use the calculator in its fractions. But I am a calculator ninja with them parentheses. Okay, now watch what I'm going to do here. negative 1 divided by 50. Notice I put my fraction in parentheses. Divided by negative 1 divided by 250. Okay, you get 5. All right? So my ratio is 5. So I've got 5 raised to the what? Plug in everything and then I'll simplify. What's n? 8 minus 1, and now I'll simplify. Negative 1 over 250 times 5 to the 7th power. I would assume that 5 to the 7th power is going to be a pretty big number. Do you guys agree with that? So let's see what it is. 5 to the 7th. Whole, that's not too bad. 78, 125. 78, 125. Now, here's my suggestion. Put it in your calculator. 78, 125 divided by 250. You don't have to put 1/250ths times 78,125. But when you do that, you should get divided by 250. 312.5, which is right on. Questions? Was that the one we needed to see? Somebody needed to see it. 312.5. Megan, you cool with that? Yeah? Any questions at all? Thank you. Thank you, thank you, thank you. Because it's negative times positive, which is a negative. Thank you. Other questions? Yeah? Number 5. Number 5. I thought that was, wait a minute. Okay. All right. Find you good with that one? Okay. All right. When I get there, we're going to do 5 first, but I will do 24. Number 5. Let's look at that one. All right. 5. What are we given? A to the A sub 12 for 96, 48, 24. Still dealing with geometric sequence. A sub 12. I got to write the formula every time. All right, I know what my first term is. 96. I don't know what my ratio is, but I know how to find it. 48 divided by 96, which is 1/2. And how many numbers? How many numbers, guys? 12 numbers. So it's going to be 12 minus 1, which is 1/2 raised to the 11th power, right on? Huge. It's going to be a huge little number. You've got to remember, folks, that when you have a power for a fraction raised to a power, that you actually have 1 to the 11th over 2 to the 11th power, okay? Now, this is going to give us a huge little number, if that makes any sense at all. That number on the bottom should be pretty big. Let's move it up here. So I've got 1 to the 11th power, of course, is 1. 2 raised to the 11th power is not going to be that. 2 raised to the 11th. Not so bad. 2048. So again, 96. And then go divide 96 by 2048. Ooh. What am I going to do that? What am I going to do? Math bracket. 3 over 64. Okay? Cool with this? All right, 24. Okay? Let's look at, pardon? No, let's look at 24. 24? On the first page. Gotcha. I was like, where's 24? No. I'm with you now. All right, 24. This is from the first page, 143. 24, here's what you were given. S sub n is negative 342. A sub n is negative 512. R is equal to negative 12. Find A sub 1. All right. This thing, I was like, what in the world? And I totally went common sense on this. What does the S stand for? The sum. Okay? Page 143 is dealing with geometric sequences and series. And I know this is a geometric because I have an R here, okay? I know that when I add up all of my numbers in my sequence, they're going to add up to equal negative 342. Do you guys agree with that? Okay? I know that my first term is what I'm looking for, but I know that my A sub n, my last term, is negative 512. Well, I know my last term is going to be over here, right? If it's my last term in the sequence. I know that my ratio is negative 2. Now, in order for me to figure the sum, so I didn't use a formula on this, believe it or not. You need to see the formula. If it is, I don't know, because I didn't do it that way. Do it, continue, all right. What's it mean if my ratio is negative 2? What's that mean? Multiply by negative 2, but I've got my last term. So if I divide, it'll take me backwards, right? So I took negative 512 and I divided by negative 2. And it gave me 256. Okay, I start here and I'm going backwards. I divided 256 and I went backwards and I got negative 128. And I divided by negative 2 and it gave me 64. Divided by negative 2 and it gave me negative 32. Divided by negative 2 and gave me 16. And I kept going. Well, did you go all the way to negative 2? Okay, you didn't go far enough. Because I stopped right here too, Anna. And I said, oh, let's check them here. And I checked my sum here, and it did not equal negative 342. So I kept dividing until I got to a sum of negative 342. Did you get the right answer?
Yeah, I got the right answer.
Oh. Okay.
Like,
But you got the right answer.
I did now.
Oh, okay. All right, does that make sense?
Yes,
Okay. Does that make sense? One very few times that I'm not going to crunch a formula. But it didn't make sense to me, so I did it this way. Okay? When I took this group of numbers right here, because I'm like Anna, I got right here and I thought, surely now, if I add negative 8 through negative 512, if I add all those numbers, it ought to be negative 342. And it wasn't. I'm like, crap. So I divided negative 8 by negative 2, and I got 4. And I added those. Still didn't get negative 342, so I did it again. And I said, surely it's got to be. It's got to be. Added them all together, sure enough, I did get my negative 342. There's always ways around, okay? And this happens to be one of those problems that I attacked in a common sense way rather than crunching a formula, because I didn't know what to do. So I know what S sub n means. I know it's the series, which means it's the sum. I know what my A sub n means, and if you know what these are, you can do these problems, all of them, common sense. Okay, all right. Other questions on the homework? The sequence in which to use the formulas. Okay. All right. All righty.
I tried to figure it out, but I wouldn't.
Okay. I will look at it. Probably won't be before tomorrow.
Oh, no.
Okay, but I will look at it.
Just if you have something.
Okay. Other questions? All right. Let's finish up. And folks, what I'm going to do with the infinite geometric series, this is really pretty simple. Okay? So we're going to finish up 11.4 notes. Yeah? Yeah, it's all good. This is very, very simple. I need to see where we stopped yesterday with the notes. Okay, determining whether it was divergent or convergent, right? All right, so here's we go. I need you to look at page 145. Infinite geometric series. What does infinite mean? Never ending, okay? We have determined that some series converge, not y'all. Some series of numbers converge on a value, on a sum, and some diverge, which means what? Goes away. And we can't get to it. There's no way we can figure out a sum. There's no sum to be found. So that's what you need to recognize. On convergent series, you have to determine by finding the absolute value of the ratio. It has to be less than 1. Okay? So the ratio is very, very important to us. When we know that that absolute value is less than 1, then we're going to use S sub n. I have to get my formula sheet out. Up, not in, because we're talking infinity. So it's going to be S sub infinity, A sub 1 over 1 minus R. Okay? That means we have a sum. We can find a sum. Because it can approach a number and get closer and closer and closer and closer and closer and closer. And we can say, oh, okay, that's the sum. All right? That's a convergent series. And then we have, does everybody have that? That way? And then, folks, we have a divergent. Again, we're going to look at the absolute value of that ratio. And, folks, when that absolute value of the ratio is greater than or equal to 1, then we got problems. There is no sum. And we're literally going to write no sum for our answer. And there will be times today when we're working a few examples, and we're only going to work on this just a short amount of time because it's just so easy. It's not difficult. I thought I was flipping out because I thought, oh, this is going to be, no, it's very easy. Very easy because it's all based upon the absolute value. Now, what do you have to remember? Well, if you look at your formula sheet and look at S sub infinity, it tells you when you can use that formula. How do you know? Go ahead, Ted. Sorry.
Ratio that
It gives you this right here, folks. The absolute value of R is less than 1. You were snowed in, weren't you? Oh, no. Okay. But there it is. The absolute value is less than 1. It tells you when to use that formula right beside it. If your absolute value ratio is greater than or equal to 1, it's not on there. Can't do it. Comprende? Okay? This is what you're given on the SOL test. You'll be given a brand new sheet, though, or it'll be online. Who knows? Are you ready for this? Very simple. Very simple. Bless you. Here's what I want you to do. I want you to look at page 145. In the workbook, and this is where we're going to get our examples from. Okay? Look at number 1. And it tells you that, well, you tell me what this means. The first term in our sequence is 1. The ratio is 1/2. What do those, and it says, find the sum. And for all of this, it says, find the sum of the infinite geometric series what's it say at the very end? If it exists. If it exists, okay? So, what's the thing we have to do? The thing we have to check first and foremost, the absolute value of the ratio. All right? What's the absolute value of 1/2? 1/2. 1/2 is compared to 1/2. It's less than 1. Does it meet the criteria to be able to use the formula? Yes or no? Yes. Happiness. Here we go. S sub n. Now let's use our formula. S, it's infinity. My bad. A sub 1 over 1 minus R every single time. What's my first term? 1. 1 minus, what was my ratio? 1/2. So, really? That's all we have to do? Get your calculator. Calculator ninjas, you ready? Oh, Lindsay. Sorry. I don't know why I cannot cut it on from here. I have no idea. Thank you. All right, here we go, folks. Parentheses, 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 parentheses. Shoot. There we go. 1 divided by, parentheses, because you want to keep your denominator separate. 1 minus, another set of parentheses, why? Because I'm starting a fraction. 1 divided by 2. Really? Seriously? Is that it? Is that it? Is that real? That's it. Pardon me? All right, but look what I'm doing, and understand why I put so many parentheses. All right, the outer parentheses is for the what, y'all? For the denominator, and then I have parentheses just around my fraction 1/2. I'm telling you, if you do it this way, all you have to write on your paper is this right here. Put it in the calculator, and it gives you 2. So the sum for that series is going to get closer and closer and closer and closer and closer and closer to what number? 2. Is that the right answer? That's it. That's your answer. Yes, sir. Why? Why 2? No, the only way we can use this formula is if the absolute value of that ratio is less than 1. If it's greater than or equal to 1, then no sum exists.
So the ratio always has to be less than 1.
In order to use this formula, The absolute value of the ratio has to be less than 1. Has to be, or you cannot use this formula. And it's there on your formula sheet. It will always work. It will always work if the ratio is less than 1. Yeah, if it meets the conditions, you will be able to find a sum. Now, this is odd to me because I have a small number for the sum. I've added up a series of numbers, but my sum is 2. Why? Tell me why. Because the ratio is starting off with a small number, and if you keep multiplying 1/2 to 1/4 to 1/8 to 1/6, what keeps happening to my fractions? They keep smaller and smaller and smaller and smaller. Okay? So this is just an odd concept, but that's correct. Yes?
How can one plus the finite values
Because the numbers keep getting smaller and smaller and smaller. If we start with a sub 1,
wouldn't you avoid them or just like
not if I continue on with that series, that my fraction's just going to keep getting smaller and smaller. Like,
how can you get closer to
how can it get closer?
some get closer to
Because you're adding those very tiny little fractions together. Think. It is an interesting concept, but you're going to find in this class that there are going to be lines that we're going to graph that you cannot, the curve that we graph will not touch a certain vertical line called asymptotes. It can get close, this close. I mean, it will get closer and closer and closer, but it will never touch that vertical line at a specific value. And this is kind of sort of the same concept. But think, if you start with 1 and the ratio is 1/2, add those numbers together. Look what's happening. Uh, 256. And on and on and on. What's happening to my fraction? It keeps getting smaller and smaller. So I keep adding a smaller piece and a smaller piece and a smaller piece and a smaller piece. Okay? Don't know that I'm answering. I can't. Okay?
is that the sum of every one of the terms in the sequence, or is it just like
In this infinite sequence. Yeah. Other questions?
it's not going to be like we took a section of it, what that equal to, or does it have to be all?
No. We're looking at the sum of the whole thing. Okay? Yes. Mm-hmm. You're given that the first term is 8, and your ratio is 2. Is that the one you just said? Okay, so let's look at it. What's the first thing we have to check? All right, let's look at the ratio. Absolute value of 2. Well, it's 2. Well, what's wrong with that? It's greater than 1. Huh. What's that mean? There's no sum. This means it's a divergent series, which is no sum. And that's what we're done. Yep. I know. Oh well. C'est la vie. Here's another one. A little bit different. It's given to you in a different format. 4 plus, number 5. 4 plus 2 plus 1 plus 1/2 plus ... Find the sum, if possible. No, I'm just saying, figure it out. You don't need me to guide you through it. You can find the ratio from that series, yes, sir. How do you do that? 2 divided by 4, which is? Aha. So this one you have to find the ratio. And now once we find it, what do we have to do? See if it follows our conditions, right? Absolute value of R. What's the absolute value of 1/2? 1/2. 1/2's less than 1. Is that a happy or smiley face? A happy or a smiley face, because they're different. That's a smiley face. What's that mean? Formula. You already got an answer for me? Megan? Go to lunch. What's the formula? Formula. Something A sub 1 over R. Nope, 1 minus R. There we go. So we determined that with this example that we can figure the sum. A sub 1 is what? 4. It's the first term. Over 1 minus 1/2. Again, Lindsay, calculator. Calculator, okay? That's all you got to do. So here we go. 4 divided by, parentheses, 1 minus, was it 1/2? 8. How about that? It is very, very facile. Questions at all? What do you think about this? It is easy, isn't it? Okay. All right, so let's look at one with a twist. Let's look at number 15. You guys go to like about minute 30 on the video and you can catch that problem, okay? So number 15, if you've got n is equal to 1, sigma to infinity, I want you to look at this. It's just written a different way, okay? Pardon me? Same type of problem, but it's written a different way because it's in that sigma notation. The thing that we have to realize when you're looking at this, folks, this number, the first number, that's your A sub 1. Okay, that's your first term. What do you think the 1/2 is going to be? That's your ratio, okay? Now, we have everything we need to be able to solve this problem. Same rules apply. We've got to find the absolute value of the ratio, which of course is 1/2, which is less than 1, which means we can do what? Use the formula, okay? That makes us happy, so let's use that formula. A sub 1 over 1 minus R. All right, first term is 10 over 1 minus 1/2. And again, with your calculator, folks, find that sum for me. What is it, y'all? 20. So far, I'm not going to ever say that it would always be that way. As sure as I do, there'd be an exception to the rule. So I'm going to crunch the numbers every time. It's very, what do we do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 keystrokes in my calculator, and I hit enter and I've got it. It's very simple. Very simple whether you have a calculator or not, because you can do these calculations. Folks, do you have questions on this? Is it really this simple? Yeah, it really is this simple. What is everything based upon? The ratio, the absolute value of the ratio. If the absolute value of the ratio is less than 1, what do? Formula. If it's greater than 1, no sum. It's that simple, okay? Questions at all? I want you to do 3 problems yourselves. Let's see. Wonder which ones we're going to do. Just for real quickly, look back at the same page, 145, and I want you to do in the next 5 minutes, I want you to do 2, 6, 7, and then jump down to 16. Do 4 problems. Can we get those done, I'd say, like 8 minutes? Same sheet of paper. I just want us to quickly go over those. Look at this. All right, now remember, this test tomorrow, the one luxury we have in math is that we can give you the same problems and change the numbers. I've done that, totally done that before. Yep. Pardon me? This starts with section, I think it's 11.2, and it goes through 11.4. Was that the last thing on your workbook? I'm thinking that's what it, let's see, because the arithmetic, sequence and series, I think is 11.2. 11.3 is the geometric, sequence and series, and I think 11.4 is the infinite geometric. Series. Okay? Formula sheets will be provided for you. Okay, so you can't come in with a bunch of little notes and reminders on your own formula sheet. I would be tempted, okay, but can't do that. So I want you to look at a couple of different things and think about things, okay? Give you a chance to get all that written down. Won't it? Won't we have to add it? So if you look at that formula, folks, where do we even start? Well, how many terms are we looking for? 3. So can I find a sub who? A sub 3 is equal to 32 plus, what do I do for n? No, before that, throw the 3 in there, because if we put 3 here, we substitute 3 for n here in the other part of the formula. I have no idea what this is going to end up being. 32 plus 2 times 4. Y'all cool with that? 32 plus what? 8, which means that gives me 40, right? What's 40? What does this mean? The third term is 40. How many terms are we looking for? 3. And I just found the third term, right? What's the third term? What's the, did I say third? Okay, what's the first term? 32. What's your second term have to be? How come? Because you add 4. So the second term is 36. The third term is 40, yes? Yes, you could have. Hello, forest. Hello, tree. Sorry. Absolutely, you could have done that. Is that what y'all were saying? Yes, absolutely, you could have done that. Say it again.
32 is a sub 1, right? The first term. Your common difference is 4. If you know that, you can do
32, bless you, 36, 40, and you know. Yep, but this is tree. Nope, that's a forest. I'm a tree. I hate these moments. What the crap? Stupid formula. Ugh. Bless you. Okay. Whatever. Crap. How about this? Questions on that? Do you have to do the formula? No, you never have to do the formula. Never. How about this one? Let's see here. Determine whether each sequence, stop talking, is arithmetic or geometric. All right, here we go. You have to determine which one's arithmetic, which one is geometric. Well, that would be a good extension of this problem. What's the first sequence you're given? -5, -2, 1, 4. Is it arithmetic or geometric? Arithmetic, which means it has a difference of 3. Is that right, Christian? Yep. How about the next one? Geometric, which means it's going to have a ratio of, you guys agree with that? Facile or difficile? Facile, I think. Hey, how about this? Everybody have this? How about this one? Let's go for a sub 5. If a sub n is 17 plus the quantity n minus 1 times, I have no idea what we're going to get. What do I do? You got this? Did you just put the 5 where the n is? Absolutely. Did anybody go common sense on this? Yeah? You can do that to check it, absolutely. How many of you got that? What term are we looking for, by the way? The 5th term. How many of you got that the 5th term was 29? Absolutely. Can I check it with common sense? Yes. Can I do the problem, common sense, and check it with the formula? Absolutely. Yep. No, I wouldn't count it wrong. No. What about this? Questions at all? Are we still on the happy side of fossil land? Yeah? Okay. Harper, are you in fossil land? Okay. Here we go. What about this one? Sigma notation. Lower limit, let's go with 2. Upper limit's 5. 4n. What does that thing? What is it? How are you going to do this problem? Quentin, how are you going to do this? All right. 4 times 2 plus what? 4 times 3 plus? See, to me, that's common sense, because that's what we're doing. I'm going from that second term. Sigma notation means to find the sum 8, 12, 16, 20. Folks, what do you get? 20, 40, 56? Yeah? Facile, difficile? Good. Facile. Probably said it wrong. Facile. Said it wrong too. What is it in Italian? Say it again. Okay. Yep. That's what he said. Oh, here we go. Here's another one. I'm going to come out with some Italian talk word. I'm going to shock you one day. It's going to shock you, and you'll be impressed. How about this? Oh, hey, let's go back. No, let's don't. Oh, here we go. How much longer do we have? 10 minutes? Is that it? Do y'all feel like we've been in here forever? I do too. Holy crap. I feel like we got more time today than ever. And I'm not offended by you guys saying that. Harper, 2 minutes would be too long for you to be in the math class, wouldn't it? Okay, that's what I thought. All right. What if I wanted you to find the 15th term of, oh Lord, have mercy. What is the value of this right here? Well, the formula might be given to you. No, you don't have to. But what if I said find the sum sub 431, Mr. Smarty Pants? Then what would you do? You would not. Liar. This one's totally doable without the formula. Do you guys agree with that, right? It's going to take time, but it's totally doable. But I want you to find the value of S sub 15. Now, the thing you got to be careful of is what? That you don't give me the 15th term. You better give me the what? The sum of the first 15 terms. And I would make myself a little note right here. Bless you. Be sure you find the sum of the first 15. Could I plug everything into the formula? Absolutely. Okay? You don't have to, but I'm going to just to show you. What would I be given? All right, here we go. I've got to find S sub 15. And I'm going to have 2 times what? 2 times 2 because that's the first term in my series. Plus, how many, what's my n? 15. Minus 1. What is the difference? The difference is 3. Yep. Say it again. This right here? This. Oh, thank you. Forgot it. What's it going to be? No, this right here. It's going to be 15 on the outside. I just forgot it. Thank you. All right, let me move that down now. This way. And then what was the bottom of that? Divided by 2, right? So I've got 15 over 1. 4 plus 14 times 3 over 2. Four plus 42. Please don't let me make a careless mistake. Is that right? Yeah? And then 15 times 23. What'd you get? 345. So what is 345? The sum of the first 15 terms, yes? How many of you didn't go formula? You still got the same answer? Totally fine. Totally fine, okay? Just want to show you that it can be done. Questions at all? What if I did the same type problem for the sum of the geometric series? Can you do the same thing? Can you do the very same thing? Okay? Can I move on? 6. How about this? Sum, that's supposed to say sum of the geometric series. Find S sub 18. Y'all think it's slick. Find S sub 18 if 2 plus 10 plus 50 plus 250. Do you use the same formula? Do we? Why not? Here's the thing, folks. When you're working this test, you will need to go through and underline certain things because you need to know which formula to grab. Some of the formulas will be given to you, okay? But we are going to use this one. I'm going to go on and put S sub 18, A sub 1 minus A sub 1 R to the N over 1 minus R. And that ought to give us everything we need. I have no idea what we're going to get. But I know how to crunch numbers in a formula. What's my A sub 1? Yep. Yeah. It will be given to you. No. No, absolutely not. No, the formulas will all be given to you, whether they're on a formula sheet or within the test. No, I would never make you know that by heart. There's no reason to know it. Yep. Why is this formula different from the last problem, folks? The last one was an arithmetic series. This is a geometric. Okay, good question. What's my A sub 1, folks? 2 minus 2 times. What's my ratio? 5. And if you don't know how to get it, take 10, the second term divided by the first term, and you get 5. Raised to the what? Power. 18. Holy crap, this is going to be big. Over 1 minus who? 5. All right, we're going to get rid of it. We're going to fix it. I have no idea what it's going to give me. 2 minus 2 times. All right, Lindsay. We got to figure out 5 to the 18th power, which is a humongous number, isn't it? It's not. All right. The formula would be given to you. Remember, we're finding the sum of the geometric series. 5 to the 18th power. Oh my Lord. Big, humongous number. Happy joy. Can we drop back and punt? Can we do this? Let's go with not 18, but let's go with 8. We're still going to work the formula. Well, I don't care which way you do it at all. But it'll make it easier on us. Hopefully. Oh, yeah. Let's go 5 to the 8th. Aha, better. 396.25. 396.25. All of that over -4, yes? Okay, this formula will be given to you with this problem. Okay? All right. So here we go. We're finding s to the 8th. S sub 8. 2 minus 2. What's 2 times 396.25? And then -79.248. Yes? Divided by -4, which gives us what? Positive something. Hold up. Did you divide? One more time.
19,800.
So what you had? Okay. Could you totally do this problem with your calculator? Yeah, absolutely. Hey, study for your test tomorrow, folks. Study all your examples. You're going to be fine.